Hello, everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala here if you prefer. Today, I'd like to talk about the North Star. Um, Supposedly, I always say supposedly because history is so. What did Napoleon supposedly say? History is nothing more than lies that have been agreed upon. So, the credit is given to Ptolemy, um, Greek astronomer, philosopher. You know, he did all that kind of stuff. Mathematician. But he supposedly named Polaris, and he actually named it Stella Polaris, which translate in Latin to pole star. Now this, if if our model is correct, the way science puts it and everything, you know, and the sidereal day is 20 minutes longer than, or the sidereal year is 20 minutes longer than the tropical year, then that's why it'll, you know, the North Pole will change and it'll point to different stars over 25,940 years or something like that. Real close to 26,000 years. But the thing is, he named it this in 169 AD. And this is, he supposedly had, you know, 800, 900 years of data to build his model upon, which is still used. I know it's still used in observatories today. You know, like in the last however many years, 100 years since observatories have been built, they don't use the Copernican model when they're putting together these, because when it was all mechanical, it all worked better in the Ptolemaic type of universe, with the Earth in the center and the sun going around it and all the planets going around the sun, and then the stars on their own separate thing. It works like a gear, even. I mean, if you look at the planets going through the sky, it looks like a spirograph. The sun's going around, and the planets are going around the sun. You know, and it makes that. It's really, really. It's beautiful. It's created when you just look at it and don't apply any assumptions to it all. It's a beautiful, wonderful, magical thing. But anyway, I digress. Ptolemy named it Stella Polaris, which translates from Latin to pole star. 169. Then in around 300, I forget the guy's name. No, I didn't write this one down. But in 300, another Greek guy found out that there was no star at the pole, that it was a void hole, that it was just black. And then by 500, Polaris again was the pole star used for navigation. Now you might be thinking, well, maybe Ptolemy just named it the pole star because it was close to the pole. But I do not think that could be the case. I took some pictures myself. I went through some of my star trails pictures that I did. And I believe I have one from 10/8, maybe October there, where you can see the Big Dipper at the start. You see Polaris there, and then you see him moving, and you see, oh, I forget the name of it. I'll write it in right here. Oh, it's early. Sorry, folks. But the star where they say it was 3,000 years ago when the Egyptians were around, and or maybe it was 5,000 years ago. 3000 BC, and then they have it at 0, and then they have it at 2000 where it is today. And if at 0, where they claim it was, I mean, there are multiple stars that are visible that were much closer than Polaris. Well, I'm going to go through and show you this, where these stars are, and now that doesn't mean that they were visible back then. There are scientists finding out that for decades, since we've had the technology, we've been measuring, how bright a star is. We've given it its scale and all that kind of stuff. And Polaris was slowly but surely, decade after decade, getting dimmer. Well, all of a sudden in the 90s, the thing starts getting brighter again. And it's supposedly 2 times brighter than normal, 2.5 times, something crazy like that, and getting brighter. Now, this was over decades. For decades, it was getting dimmer and dimmer and dimmer and dimmer. And now it's getting brighter, and it takes a long time. And if you don't have the proper measuring tools to do this, do you think they could really... I mean, in 300, when I don't even remember the guy's name, I apologize, but when he discovered that there was no pole star, what if it would just dimmed out to almost nothing for, a few decades, 2 decades? It was just barely visible to the naked eye, very faint, or not even visible at all to the naked eye. I mean, we don't know what happens over hundreds of years and thousands of years, and we've really just started scratching the surface of actually collecting real data on these things. I mean, the data is true, where they are and all that kind of stuff. That's great data to have. But as far as the pulsation of light and what they are, and I mean, down to the, arc second measurements and stuff like that, that's all been happening in the last few hundred years. I mean, on a grand scale of things, we don't even know what they are, where they are. There's so many questions that need to be answered before you can actually start building your model. I mean, these are all assumptions that they're basing everything on. And the stars have been getting further and further and further and further away over these hundreds of years. Everything has. Because the further we can see, the more we realize that it all sets itself back to its original. The pole star, it may move a little bit and rotate a little bit, but it's not this big giant arc that I'll show you the arc here. I mean, just look at this thing. Look at how big of a circle in the sky this is supposed to do, and it's supposed to do 1 degree every 72 years. Which you wouldn't think would be a very big, and it's not really that big, but, over 2,000 years, that adds up quite a bit to be a huge amount of sky. I mean, a huge amount of sky. And the fisheye lens just makes it all look smaller because you get such a grander view. But when you're outside actually looking at this stuff, I mean, you look at it and it's a big portion of the sky. And to think that they thought that the pole star was here, but it was actually making a huge arc like this going around the thing. Why would you name that thing a pole star? It would not appear to be the pole star back then. Not if it is right now, then back then it could not have been. You can see on the thing where it should have been. I'll throw it up here again. I mean, it's just, they say it's back then it was here, and at 0 it was here, and now it's here. Well, if it was 0 then, why would you call it the pole star? I mean, the Polaris actually comes from the word meaning polar star. 116, I mean, they can't hide this stuff. Was Ptolemy that inept at his job, at what he was doing, to name that the pole star? I mean, you'd get called a buffoon today if you tried to name one of the stars as far off as the pole star was the pole star right now. Take away the pole star. You know? I mean, do we have a southern pole star? Do we have a southern Polaris? Or whatever they would... I'm not even sure what you would call it. But no. There's Sigma Octanus, the closest one, and it's super faint, and it's blah, 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 and it's really just a black space that everything rotates it around. No, there is no southern pole star. They would have given it some sort of name like that. And I don't know. I still haven't done a whole lot of... I've never been to the south of the equator, so I don't know. I would love to sit there and track it over a year and see where the pole star stays or if it moves. I mean, there's so much data that needs to be collected on this stuff and shared, and the truth needs to come out. What are you doing? Stop it. I'm making a video. You stop it. You poor lady. You poor lady. Playing with one of the kittens. Well, not a kitten. She's a cat. She's my baby, though. But anyway, okay, then we'll fast forward to 500, where they started using the Polaris for navigational purposes. So since 500, so 1,500 years later, it should be over 15 degrees off. I mean, well, let's see. It's well more than that. We'll just say 75. It's like, wow. It is crazy. In 500, it was used as the North Star, as very near 90 degrees north. Right now, it's 89.43, or it's a little ways off. But I don't know if it's ever been exactly 90. You know, it's just, and it could rotate a little bit. It could go in and out, and there's so many things that we don't know about, or that could be known and just aren't shared. I'm not saying nobody knows these things. How could I couldn't know something like that. But okay, we're going to fast forward 1700s. You know, we have telescopes now, highly advanced telescopes that can measure down to the arc second, and there's these guys building them in observatories, and they can see stars during the day, and if they're bright enough. And I mean, they were doing real data and research and collecting. And this guy, James Bradley, I got it wrote down. And you can go look him up. They got some of his, but he discovered that some of the stars, they call it circumpolar navigation. And you have the pole star, Polaris, and the stars that go around it and form a circle, they call that circumpolar. And there's this thing called circumpolar parallax, or aberration, they call it. And it's where stars appear to move backwards. Like 3 months they're moving forwards, 3 months they're moving backwards, 3 months they're moving forward, 3 months they're moving backwards. And they say it is due to the speed of the Earth speeding up and slowing down, and the amount of time it takes the light to get through it. Now that would kind of need ether to do that, because light would have to travel through something in order for speed to be affecting it. Like something moving through a vacuum, light coming down into it. I mean, once it hits our atmosphere, that'd be different. If you're saying the atmosphere is affected by the speed of the Earth, but we all know that the air and the atmosphere and everything is attached to the Earth in unison, and it's all spinning at the same rate, right? That's what we're told. So their whole idea of it taking longer for starlight to get to this point, and I have to aim it a little bit ahead, you know, or a little bit behind, and it's not in the same spot, blah, 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 because of the speed of the Earth going around this, only makes sense if there is ether, which Einstein abolished. So you can't have it both ways. That's why they totally don't even talk about stellar aberration anymore. Because without the ether there, stellar aberration should not occur. To my understandings, I could be totally wrong on this. I may not be perceiving it just right. But the way they explain things, you need some type of a fluid, whether it be air or liquid or something, to slow the light down if you're moving, you know. But if it's just hitting the atmosphere and the atmosphere is always spinning at the same constant rate and blah 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 blah, then that should never change. Moving something on the, through a vacuum wouldn't change it. Now moving something through ether would change it, because the light has to travel through that ether, which was believed to be around back in the 1700s when they wrote this off as being that. So I mean, Einstein threw a wrench in a lot of their, but then again, they don't talk about this. They don't talk about, yes, there is a parallax, but the parallax corrects itself. It's like somebody has their hand on their watch, and every 3 months they go, oh, I'm off a little bit. Click, click, click. We'll go back a couple minutes. And now I'm all set again. I mean, that's how my watch works. Every 27 minutes, my watch will get 1 second faster than it should be, according to the atomic clocks. Now, I don't have it down to the nanosecond or anything, or a millisecond or anything like that, but about every 27 minutes, I've done it multiple times. Haven't done it in a while. I should see if it's still doing it. But I mean, that's not horrible. 1 second every 20, but about every day I'm a minute faster. About. And I have to set it back every few days. Once a week I'll put it back 5 minutes. And it's just, nothing is built perfect. If this is built, this whole place, then it's understandable that there would have to be things that were reset. If it is an actual structure up there and it's mechanical. I'm not saying that it is. But there are things, and it could just be the way, even if it isn't mechanical up there, even if, I don't know what the stars are. I have no idea. If they're projected up there, the mechanical device that is doing the projecting has to be reset. It's almost too perfect in unison the way it all works. Here, let me go on to tell you what else he says. The amount of parallactic shift should depend on the star's distance, larger for closer stars and smaller for further. Yet Bradley observed it was the same for every star in any given region. So depending on what region of the sky it was, to determine on how far it moved. And they're looking at stars during the daytime as well. Back in 1727. I mean, it was amazing. And that's all I wrote down for the Bradley guy. But it's amazing that we aren't taught this stuff. Well, it isn't. I mean, when there's a deception and people are lying to you, they have to hide things from you. So there's a reason we're not taught any of this stuff in school. Because if you think of their model, the stars cannot go backwards. That would mean the Earth is rotating backwards, or slowing down and then speeding up its rotation. And that can't happen in their model. It cannot. It is not allowed. In fact, when it is marked, there's a certain amount of negative parallax. It's like so many percentage, 0.02 arc seconds or 0.2 arc seconds, something teeny tiny when you're measuring up in the sky. Now, if that were to be that certain amount, it's all right. But they're finding it 2 to 3 times greater than that, and they just put it as a 0. They'll mark it off as a side note, but it's not used in the overall. And there's your negative precession. So if we look right here, I'll show you. You'll see Polaris is right here. And you'll see later as the stars start moving and they make the trails. And you got your Big Dipper right here. And then this is where it was during the Egyptian time, supposedly. And then around Ptolemy's time, it was right around here. Now watch this as these move. And tell me if you think that Ptolemy was that big of an idiot to name that star the pole star when it was this far off. Now you see this next one, the stars move a little bit. This is just only over about 2.5 hours. So I mean, when you're watching the stars the whole night, how could you mistake these? How could you mistake this? It would be crazy. And then you go again a little bit more, and then again a little bit more. Now you see that one star stay right there, and all the other stars moving. I mean, to call that where it should have been at his time, to call that the pole star, it would be making a huge arc like these other stars. It's ridiculous. It's nonsense. I mean, these are the ones who came up with the model, yet we're calling them, you say, oh, they didn't have good technology, blah, blah, blah. They must not have got. They didn't get that part right, but they got everything else right. Like, amazingly accurate how it all just kind of falls in with how it all works. Nah, I'm not buying that. So, yeah, there is something going on up there in the sky, and we have no clue what it is. I don't believe anybody knows what a star. Well, I can't say that. Things happen to people, and people. I don't know. I do not have any clue what the stars are. None whatsoever. Sun and moon, same thing. It's beyond me. Well beyond me. I know how they move in the sky. Well, the sun very well. The moon, I'll start learning here. But the sun, I've been tracking, and as far as observatories go and the data that they give us, they seem to be very, very accurate. A few days off by a couple degrees with my sextant measuring it, but it wasn't a perfectly clear view of the sun. There was clouds. There was, I need to start measuring humidity and stuff like that. It takes time, folks, and this isn't my job. It'd be really neat to be, but I mean, I've got to eat, and I've got to keep a roof over my head and all that kind of stuff. And this doesn't pay the bills. So but right now it's horrible around this area for collecting data on the sun or stars or moon or anything like that during our winters here, northern Indiana. It's not gonna happen. Not if all the years are like this. Like I said, this is the first year I've really, really paid attention a whole lot. But sun doesn't shine here very much this time of year. It just doesn't. It's horrible. It's making me want to move somewhere, but I don't know. But yeah, I just want to apologize. I know, I mean, at work we've been so busy. We've got a bunch of new machines in and stuff like that things need to be set up and processed. I mean, we have giant amounts of power and giant amounts of water that need to be set up and hooked up, and we had to get a lot of new machinery just for these machines, and we don't have time to goof around at work at all right now. I mean, there is no downtime, so there is no cutting into steel to make a platform for my gyroscope right at this moment. It's just not going to be happening. Too much going on. No time for government work. But, yep. It's still all, I mean, I still got it. It's still in the books and all that stuff to be tested and all that kind of stuff. I got my laser and I've been playing with those a little bit. Like I said, I've been trying to pick up hobbies to take my mind off the sun not being here. I really apologize to all y'all for slacking this winter. But it not being around the sun, not seeing it, really, it does affect people. It affects me for sure. And I'm not apologizing for that. I'm just apologizing for just not being around the last month or so. It's been weird. It has been. Very, very eye-opening experience. But yeah, that's it. I'm gonna get going here. Check out aberration, stellar parallax, and negative stellar parallax, and how it all works. Um, it's really something that really just destroys the whole heliocentric model and the way they claim that it all works. It's laughable when you really look at it. It's mathematics. That's all it is. Theoretical mathematics. And it's a shame. It really is that they're teaching this stuff to children in school. Um, we are living in the dark ages right now. This is what it is like to live in the dark ages. Right here. This is what, maybe not that dark. Maybe it gets darker when enough of us wake up and then they have to suppress it again. Maybe that's what happened during the dark ages. I don't know. You know, history is nothing more than lies that have been agreed upon. In some people's opinion, at least. So, saying that, oh, one more thing. Get out. It's time to start telling people about this face to face, folks. If you really want to spread the word, that's the best way to do it. People are really, I mean, they're seeing it more. I mean, I live in nowhere, Indiana, where I'm not going to say that because it's horrible and I love all these people. But we get things so much later than everywhere else. Even down the road, just, I mean, things hit here and it's not as bad as it used to be with the cell phones and everything now and the internet. But, I mean, you could see a big gap and difference in, like, I remember when I was a kid, I lived up there by much closer to Chicago. I mean, we were a suburb of Chicago considered, even though we were in Indiana. It's just all one big giant metropolitan area. And then we'd come even further out into the country than where I live now. And I had a cousin who had a farm out there. And like MC Hammer Time had been gone for like a year and a half, 2 years, and it was just hitting out there. And this is only, 60 miles down the road. 50 miles. Well, about 60 miles down the road. It's not as bad as it used to be, but it's a different world out here, and I love it. I'd never change it. But yeah, it's nice. It is. I forget where I was going with that. That story just kind of made me laugh. But yeah, I'm gonna get going here, folks. I just wanted to apologize for not being here so much, and I hope you all look into the stellar parallax and aberration, negative stellar circumpolar parallax, blah 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 blah. Bunches of big words. Stars moving backwards from where they should be. And like the Earth is rotating backwards. It's just ridiculous nonsense, and that's all it is. Theoretical mathematics, folks. And well, I'm not saying we were all fooled. Not everybody, but I was fooled. When I was a child, I remember my mom telling me about gravity and that we were on a spinning ball, and I just laughed at her. I said, "No, we're not. Why aren't we all flying off into space? That doesn't make any sense." Well, gravity. Well, what makes gravity? Or the Earth spinning? Or something. When you're 4 years old and they're explaining this stuff to you and you start asking questions that they don't know, I wasn't an only child. There was a lot of kids, and I'm sure my mom just said something. So it was like, "Hey," or "We'll look it up." That was, my mom said that to me a lot. "We'll look it up." And we did look up a lot of things. And we probably did look up gravity, and it was probably exactly what they told, they're not sure. Or I don't ever remember it was being the attraction between two masses. I always remember the way my mom understood it, it had something to do with the spin and the rotation. That's what she was taught. My mom is an intelligent person. She's very bright. But yeah, they keep having to change everything, folks, and that's just a true sign of deception, that they do not understand what they are telling you. They don't understand it. They're just making it up. And the sooner we all realize that, the sooner we can start freeing ourselves. This place could be great. It will be great. It is great, really. We only let them, they only destroy what we let them. Remember that. We are in charge. We are so in charge. As an individual, we are all capable of so much. And we have to get away from herd mentality where one person screams something and everybody just does it. We have to be united, but yet we have to be individually united. We have to keep our wits about us. And this could all go away very quickly. But it's probably not going. It's not going to. Anyway, I'm rambling. It's real early, and I'm rambling. So I'm gonna get going here. I'm gonna make some more lock picks and listen to the more guiles. Tear apart this guy some more. I love seeing a lot more people come out and speak out negatively or against the flat earth to all their followers. Because all it does is, anybody with a brain that is looking for truth, they know how to find it. This guy, the more guy, okay, I'm blah, 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 I'm rambling. But John, you did a great job again. You're doing amazing work. You and Jaron on Glowbusters are doing awesome. Just really well put together programming and very informative, and I've been learning a lot from you guys. I do a lot of research, so we have to go look up this stuff. Whenever I see something that you guys put up, I always go look it up myself. No offense or anything, but I just don't take anybody's word on anything. We misread things. We all make mistakes, and that's the only way you know, folks, is to go do it yourself. If you want to know, nobody can tell you the truth. You have to go look at it and see it and analyze it yourself, and don't care what other people say about anything. You have a brain. Use it if you want to. If not, then don't. It doesn't matter. But don't call other people ignorant or stupid or the R word, for using the scientific method and using their brain. It makes you look very simple and very foolish, really. Even though all the other foolish, simple people are laughing with you, wow. Okay, I'm rambling. I am really rambling. But anyway, I'm going to get out of here. This is Good Times for All, folks. Signing out. If you made it this far, thanks for watching. We'll see you.